We are picking up from where we left off last time, which was our scope was dead. Pressing the soft power button got nothing out of the scope. So what I have done and what I have here on the bench is the low voltage power supply from the TDS 420A. The AC comes in here, live neutral ground, and comes out here in various voltages across 22 pins. So the first thing I did was I applied some power to it and I found out what was going on. But before we go into the details of that, I'd like to show you a little bit of what we took out.
The first thing I did was replace a half dozen capacitors, and I replaced them with good stuff from Mauser because that is the only way to go.
This is the Capacitor Police. We approve of this video.
Even after replacing the capacitors, we heard a ticking noise. That ticking noise was coming from the transformer and was caused by the PWM modulator chip. We tried replacing that didn't work. We tried replacing the TL341 that we just showed you, and then we tried replacing the optocouplers, but that also had little to no effect. A further look found a bunch of little diodes that were shorted, as well as a Schottky module that was shorted, and even a couple of little capacitors that were shorted or way out of spec. Replacing all of those did little, but did start to bring our voltages into line. So we continued the work. We'll take a look at the result, but right now, let's have a quick word. And now let's have a look at the voltages. First up, I'm using the multimeter on my Tech 465B oscilloscope. The minus 15 volt rail is not coming in correctly and is between minus 9 and a change and minus 12 and change. That is not what we need to see, and the problem is that the triggering rail is going to be off, as we will show you now. Let's head over to the other meters. The 6 volt rail, negative 6.1 rail, is close. It's really close. The positive 15 rail is also very close, but the positive 5.1 rail is low. So that's where I put my effort. I figured that if we could get the 5 volts stabilized, the other ones would lock in and we would be able to power up the scope. So I did a little bit more research. The ticking sound continued. That is a classic switch mode power supply hiccup. I looked for ways to stabilize the 5.1 volt rail, knowing that if I did that, the other voltages would fall into line very nicely. However, that turned out to be a real challenge. Everything I did was failing. I could not get a stable voltage on any of these rails. At that point, Jared from Near Far Media, YouTube channel NFM, go visit him, gave me an idea. Jared suggested that what I needed to do was to load the 5.1 rail and perhaps the other rails in order to get some kind of an accurate voltage. Put resistors between ground and the load pin and see whether or not that load would cause the power supply to slap into place. It worked. It did bring the power supplies into line by putting large heavy-duty resistors onto the power supply rail for 5.1. I had also tried it with the 15 volt rail, but that was unnecessary and did nothing except bring that rail down. And at that point it was time to put the power supply back into the scope, pray, and see what would happen. First I started to remove the test leads. I removed the test leads and then I removed off the power supply leads that were going from the outputs. At that point we were ready to put it into the scope, but there's always a first things first with something like this, and that is when you work with a power supply with large capacitors, you drain those caps first. So I got out my trusty capacitor discharge tool built with a Mendit Mark design, and I checked, and sure enough there was voltage on both of the big bulk capacitors that were going in from the AC supply. I drained those out and it was time to put the unit back into the scope. So let's get started with that. However, one thing popped up. When I was getting ready to put the power supply back in, something caught my eye, and that made me immediately remove the EMI filter from the scope. It was a good thing I did. This is the preliminary power input on the scope. This is where the power goes in. There's a power switch and a fuse on that board. The other thing were those two little caps I just pointed up. Those are REFA capacitors, and they will blow up badly if you do not take care of them. I pulled out both REFAs, and this is what I saw. They look okay from this camera angle, but they are not. I'm going to put some light on them, and you're going to see that there are cracks, horizontal cracks, on both sides of both caps. And that means that they were getting ready to blow. Just like on the 2465B I worked on in episode 2, the REFA caps were at end of life. So I replaced them with fresh REFAs, yes. Mauser sold them to me. Mauser is correct. Kemet bought REFA a while back, and the REFA caps are workable now. Newer REFAs are good for 30 to 40 years, and you don't have to worry about them. So I began to reassemble the scope. I put back the EMI filter, and then I began to install the LVPS back into the scope. I connected up the backplane wire, the pilot wire for the soft power, and then the power itself, and then I powered up the scope.
Here we go. Well, here goes nothing. My friends, this just may be time for celebration. This looks very, very good. That is the normal display you see on a Tektronix TDS series scope when it's powering up. Let's see if it goes all the way through. We're waiting for the galloping horses relays. And there they are. And this display is starting to come up. And I'm going to move in a little bit because the next thing we're going to see, self-check passed. Option 1F, which is the floppy drive, is there. We are in business, my friends. And now I'm going to go ahead and I'm going to put a little bit of signal into the scope before I have to shut it off so it doesn't get too hot. Okay, we've got 1 volt at 1000 hertz. Let's do this. That looks pretty darn good. Let's do the other one. That also looks good. My friends, the scope is back from the dead. Now, one last thing I want to note is that when the scope is powered up, the second you hit that soft power button, the ticking stops. That appears to be that the ticking is a sign that the power supply is in an energy conservation mode. But we're not going to worry about that too much at the moment. What I'm going to do is when the scope is on the bench, because this is joining my bench, we're going to make sure that the scope does not have any problems. And I'm just double checking and listening carefully. I hear the fan, but I do not hear the ticking. Let's see what we can do with this thing to just make it a little bit more fun.
I need a pimp my scope. Yeah. I need a pimp my scope. Yeah. I need a pimp my scope. Yeah. Turn it up. Turn it up. I need a pimp my scope. I need a pimp my scope. Let it roll. Let it roll.
I bet I sense a little bit of confusion here. You see the bench. You see a cable clamp. You see 2 barrel jacks with 9 volt adapters on them What does this have to do with making my scope even cooler? Well, we're going to see right now. First of all, we're going to cut these in two. And we're going to keep the two barrel jacks, and I'm going to get a length of red and black wire. Let's go with about 3 feet worth, give or take.
And at this point, I'm going to go ahead, strip the ends, put on some shrink tubing, and do it before you solder, and solder the connections together to make clean splices, red to red, black to black on both sides. The idea is to make a straight through barrel jack to barrel jack adapter. And you'll see why we're doing this in a short while. A quick continuity test to make sure that everything is in order, and we're done. And now we're going to add an option card into the scope. This option is called Option 13, and what it's going to do for us is going to be pretty darned cool. Option 13 contains 2 ports on the back of the scope. One port is a serial port, the other is an old-fashioned PC parallel port. And now that I've got the scope plugged up, you get to see what's going to happen as I attach this parallel port to the scope. And now it's time to meet our new accessory. By the way, also on the back of the scope is a connector for that barrel jack power. And here is the printer that we will use to print with our oscilloscope. This is a Seiko DPU411 thermal printer. As you can see, I'm fumbling with it. I'd just gotten it in about 2 hours before I started recording this segment. And what I'm doing here is trying to feed the paper, but it's not feeding. The printer is actually a touch older than the scope, 4 years older to be exact. So the printer is 34 years old, and it was just a little bit gummed up from having sat for many, many years. So what I ended up doing was opening up the printer and looking on the inside and checking the gears because I thought I heard a gear pop when I was trying to feed. I got the printer open with a little bit of screwdriver work, and I looked at the gears on the printer, and sure enough, I was able to free things up. At that point, it took the paper in for a feeding, and it was time to run it through the scope and see what would happen.
So in order to print hard copies off this scope, we need to do Shift Hard Copy, set it to, let's check more first. There it is, DPU 411. Okay. We've chosen DPU 411. Layout Landscape Port. We'll use Centronics. Clear the spool. Okay. Close off the menu, and what happens if we hit hard copy now? Hard copy in progress, press hard copy to abort. It acted like it was printing something, but nothing came through the printer. So, this time let's turn on online and try it again. Wait, we don't need to. It's printing.
I've sped things along because it takes approximately 4.5 minutes to print one screen. That seems like an interminable eternity in today's technology, and I'll take a look at it. But what I did is I printed the blank screen first, and then I put in some signals and printed those. After those two printed successfully, I went ahead and reassembled the printer, fed in a different set of signals, and did one last print. Pimping number 1, option 13, was a complete success. The printer now works, the scope gives the power to the printer, and we're ready to move on.
Okay, we're back on the bench. The scope is up on the bench. It's a little dry today, so I've gone ahead and attached a ground clip to the scope, and I am wearing my ground bracelet here. and that connects to the grounding system, which I will show you when I tour the laboratory out. Anyway, what we're going to do is we're going to take this console cable that I made here and we're going to connect it here on the scope, and this is going to be what we use to apply the options that we're going to add to the scope at this time. We're going to connect that to a serial port on my computer, and I'm going to fire up the scope. And now you're watching the scope powering up and booting. Hopefully we won't see any errors, but so far so good. And the screen on the front looks good. And it is going ahead and it is firing up. The galloping happened, and now we're looking to see if there's any kind of a glitch on the startup. The operating system, that is a normal boot up, and on the front of the scope I am looking at power on self-check passed with options 1F and 13. We installed option 13 a few seconds ago, and now we're going to move on. Okay, the scope is operational. We're going to try and do this fairly quickly. I'm going to hit return and you're going to see a prompt. I'm going to do the I command, and that's going to show the running processes in the scope, and that works well. Now, Tom Verbier a few years ago did a special report on this, and what he did is he showed us how to do this. Option 05 is the video triggering option. That's not going to be too useful for us because it's for old analog television. Option 2F is advanced DSP math, things like fast Fourier transformation. We're going to take both of these guys here. We're going to copy these up. Let's do it right. Oh, it doesn't want to copy with the key, so I'm going to do Command C for copy. And we'll go back to our screen here. Command V. And hit 1. Okay, it looks like it put in the 050007, but not the 05009. So I'm going to go back and copy that, and we're going to reapply that. And then what we'll do is we'll restart the scope. Okay, that's all done. The scope is going to get warm pretty quickly if we don't move our butts. So I've done that. I'm going to clear the data off the screen so we can watch it reboot again. And we're seeing it reboot. And I'm going to try and capture the front of the scope in video mode with my third camera, which right now is my phone. And it does seem to be working perfectly. We're waiting for it to come up, and if it does, we're in business. Power on self-check passed. 05, 13, 1F, and 2F. All of the options are up on this scope, and we are looking really, really good. Next up, demo time. Okay, the scope is firing up nicely, and we're waiting for it to fully boot, and we're getting there. And while that's happening, I'm in the background setting up a function generator so we can demonstrate FFT. Okay, I've turned on the fast Fourier transformation, and because this is a square wave, you could see all of the harmonics showing up right along here and right along there. So that gives you an idea that the FFT is working. Now, can we move it around a little bit? Yeah, we can do this. We can move the math down here, and then we could take channel 1, we can shrink the square wave and move it up, and you can even see what's going on here. So that is how fast Fourier transformation works. That's basically a spectrum analyzer. So what you could do, for example, if you're doing audio, is you could feed an audio signal in on channel 1 and do an FFT and see the waveforms of that. You could feed a radio signal in and see where your tuner is tuned, for example. That's part of what you can do with this beauty. And that is now active on this scope. So now with this done, all of the easy stuff with pimping our scope.
Okay, we're going to go ahead and start off by putting the power supply securely in. We're going to screw it in with the one screw and then add the fan. Before that, I went ahead and took the large output caps and secured them with silicone. Next up, there are some braces to hold the cards in firm place, and then the screws. Unlike normal PC cards from the era, there are screws that went in the bottom and into the top. I installed all 10 of those screws and had no problem doing so. After that, everything in the card cage was secure. With everything secured, we had the fun part, installing the gaskets. And you're thinking, gaskets? Yeah, gaskets. They are electromagnetic interference gaskets. And you think, we don't need them. Oh yes, you do. They make a huge difference in the amount of interference that gets into the scope. And believe me when I tell you it's sensitive. These are needed. It took a little bit of shoving and a little bit of spudger work, but I got them in there, and they're in there the right way. And now it's time to case up the scope and start putting it to use. And now it's time to case up the scope. In order to get the case on the scope, first we bring the case up and we install the handle. The handle is made out of plastic, and you pry it apart and snap it onto the case. And as you can see, I fumbled just a little bit with it. They have these weird spikes which hold it into various positions, but in all, the handle is designed fairly well. Then all we have to do is attach 2 self-tapping screws into the plastic, and as all the other screws are on this, they're headed with the T15 Torx. Once those are in, then the real fun begins, because we have to wiggle the scope into there without hitting any ribbon cables and without doing any damage to the gasket which we just installed. So I grabbed the handle and flipped it out of the way, and from there on we began the work of sliding the scope in. It became apparent that the way to do it was to put the scope upside down onto the workbench and begin sliding that away. And then as we moved in, we would rotate it, and as we did that, we would make sure that we could get in a position where we could keep the ribbon cable safe from being smacked. Then we had to put the scope back down on its front end, after of course adjusting that gasket carefully. And while we did that, remember the weight of the scope is on the buttons, we pressed it on the edges of the scope to make sure that everything fit properly. Luckily for me, nothing went sideways. And at this point, we were ready to install the back cap of the scope. And here it is. But before we did that, we needed to go ahead and put in the power cord. So I grabbed up the power cord, and believe me, when I first took it off the scope, if you look at the previous episode, this thing was trashed. It was just covered in grime. It took me 45 minutes of hard scrubbing to clean it. But it's clean, and it's ready to go back in the scope. There was a little bit of a strain relief which goes in, and it snaps in, and I snapped it in off camera, sorry about that, and then we put it on the scope. At that point, all we needed to do was begin to screw it back in. On the back, there are 4 screws, and we inserted those fairly rapidly, and they went in very easily. They came out easily too, so this is no surprise. Once the screws were in, we were in a place where we could install the final screw, and then we would be in a place where we could begin the work of putting it into the bench into a nice place of honor. So here it is, putting in the last screw, the set screw that holds the case in place. This is something that didn't happen in tech scopes before the 428 or after.
I am going to go ahead and wind the cable on right now, just to make it a little bit easier to handle, especially when I have to hoist it up. In the next video, I will take a few minutes to tour the bench if I have the time in the video. When it's done, you'll see just how awesome everything is on the bench.
And now, with it being up in the bench on its place of honor, I fired it up for the first time while it's on the bench. And of course, without hitch, it comes right up. With the scope up on the bench, I immediately applied some signals. First, I put a sine wave in channel 1, and then I put a sine wave in channel 2. I then turned on the math functions, added 1 and 2 together, and then I played a little bit and subtracted them. The line means there's no difference between the signals. Then for giggles, I changed the waveforms around just to see what the math would do for the difference between them. The patterns were interesting, but they really didn't do anything scientific. Then came the ultimate test. Can you make a digital scope show the John Tinker's logo? The answer is yes, you can. As you can see here, the logo showed. It wasn't the prettiest one in the world, but it is a lot better than cheap Chinese scopes could ever do. And of course, it takes Tektronix skill in order to make it happen. Now, I must admit that my analog scopes can do a heck of a lot better job with this than the TDS 420A can. And believe me when I tell you it was a half hour worth of doodling to get to this point. But it was fun, and we know it works. Now, for the ultimate use for this scope on the Tinker Bench. The scope has the ability to put out a signal on VGA. So I'm capturing that signal, and I'm going to be able to put it into a corner of the screen while I'm doing work, and we'll have real-time feedback of what is happening as I'm actually testing the gear. You'll see the probes go in and the signal on the scope. Here are some real signals showing on the scope. These are just randoms from my signal generator, but they do show that the entire system works. I was able to adjust color, and I'm able to adjust features at the time that the scope is displaying. Here I'm doing a simple math subtraction and putting on the silly patterns you saw before. They all work well, and that means that this Pimp scope is going to have a huge, wonderful future on the Tinker Bench. And with that, I thank you so much for watching. Please like and subscribe this video, and please hit the bell so that you get notified when we put out our new videos and shorts. Please join our Patreon page. I'd be happy to have you there on the free plan and to get notices of what is happening on our channel and to be in communication with us. Thank you again so much, and may you have joy unspeakable and full of glory and the peace that passes all understanding.